Dream to become the next Sir Isaac Newton or Albert Einstein? Learn from the master, Refath Bari. Watch his videos to achieve your dream.
Alright folks, welcome to Special Relativity Lecture number 17. We're live here from the Bronx on the streets of New York. We're doing Maxwell on the streets, folks. Okay, we're doing Maxwell's first equation. This is a really nice example. This is a continuation of the previous lecture, so make sure you watch that. In the previous lecture, we found that the area of our differential surface was what? We had our length as what? R d theta, and we had our height as what? R sine theta d phi. Okay, so that means the area of our differential surface is going to be the product of the length times the height, right? Because what is the area? Length times height. So we just multiply these two. So R times R will give me R squared, and then sine theta d theta d phi. Okay, but we're not even done, folks. What we're going to do is integrate this over the surface. So perhaps we can come over to it and let's go ahead and integrate, okay? So try to understand what Maxwell's first equation. Try to recall what Maxwell's first equation was. It's simply that the closed surface integral of the dot product between the electric field and the normal vector times the area of whatever surface we have. But now we're dealing with a spherical surface. So we're going to have cosine of 0. And of course, cosine of 0 is simply 1. So that means we're just going to be left with the integral, the closed integral of the surface over the electric field times dA. Okay? Everything looks good? Everything looks good. Now, the electric field is simply kq over r squared. And it doesn't have any of the differential parameters. So we can just treat it as a constant and bring it out. So, boom. So now we're just left with the integral of dA, folks. Okay? So let's go ahead and find what that is. So, we're simply going to have the double integral of theta and phi. And we're just going to plug in what we had before. Right? R squared sine theta d theta d phi. Okay? And of course, this is a definite integral, so make sure you put your bounds as theta 1, theta 2, phi 1, phi 2. Okay? As soon as you evaluate this integral, you have your electric flux. And evaluating this integral right here, this double integral, is going to give you your electric flux. Alright? So we'll check that out in the next lecture. Thank you for watching.
How is your feelings of solving math problem on the street of Bronx?
I love Bronx, I love Maxwell, and it's even better when they're both together.
Do you have any problem solving mathematics on the street of Bronx?
Actually, I have more solutions than I have problems, as you've just seen on the
What
board.
is the reason behind solving problem on the street rather than in the board at the home?
Well, in the home, nobody sees you solving the problems. At outside, people, you're really popularizing the mathematics for the whole Bronx community.
Subscribe to Bari Science Lab to fall in love with math and science, especially programming.